Right then, making a flowchart. What we're going to look at today is how you can make a flowchart, what it's for, when you should do it, and some of the symbols within it. So let's get started. Now, the thing you need to know about computers is basically you're taking data, going into it, you're doing some kind of sorting, asking questions, or doing some process to the data, and you've got some outputs. Here we've got a nice simple flowchart. We've got some data going in. We've got some red balls and some blue balls. We're doing a bit of sorting. We're saying, is the ball red? Yes, no. And our output is two different boxes, one for red balls, one for blue balls. This is a very simple flowchart. This is what's important. You have to start thinking about this before you get into the programming, because if it goes wrong when you're programming, it's a much harder job to fix it. So let's look at a system where I got it wrong. Let's look at a bad flowchart. Now here we have a bad flowchart. I haven't planned this properly. Yes, I've got some inputs and I've thought of some outputs, but it's a bit chaotic. The questions, I've got is ball red twice. It sort of works, but then only when I did the flowchart did I realize, well, hang on, what about the purple one? If you look, there's a purple one that's coming in the input, but I forgot to deal with it. It ends up getting bounced out of the green box down at the bottom. So this is overly complicated. I haven't asked the questions in the right way, and I haven't taken into account one of the main inputs. And I found out that I've done it all wrong right at the beginning in the design phase before I've even touched the keyboard. And that's going to save me a lot of time, because if I'd found this out later, I'd have had to throw all my programming code away and start it from scratch. So the great thing about flowcharts is you can get all your thinking about what processes and what flow is going to happen before you start writing the code. So let's, I've worked out, oops, I made big mistakes here. This was awful. I forgot the purple one. Let's get it right. So I redesigned my flowchart, and here we go. So it's much simpler, it's more straightforward. And you notice on the bottom now, I've got an other. And the purple one is, I haven't said, is there a purple one? Just anything else is dealt with in the other box. So I've thought carefully about my inputs, my processes, my outputs, and the way I should ask the questions. And this is the purpose of flowcharts. It's a design tool to make sure you get it right first time. Thinking about what goes in, what comes out, and what to do in the middle about processes and questions. Okay, now, most computer programs never stop running until you actually cut the power. So if you look at a traffic light, it goes through a sequence and then goes back to the beginning. Well, let's look at this train. This train's going through a sequence. It's picking up, there it's picking up a red ball, here it's picking up a green ball. We're getting some sorting there, some storing, there goes the red, brown we come again, another question, and off it goes to store in the process. And it's ready to do the whole thing again. It's like a big loop. If we look what I've done here, I've actually started to use flowchart symbols. The parallelogram at the top there, that's an input. So I start by inputting data. It wouldn't be a physical input, it would be information or data. Here goes the green, inputting more data. Now I've got a question going to a rectangle, which is for storing that data. And again, another question, and I'm storing that data, and we get back to the beginning. Now, when you're drawing a flowchart, you would never draw a train track. You wouldn't draw it like this. On the next slide, I'll show you how this process would look if it were a flowchart. So here we go. At the very top, we have a terminator. That's a start or stop. Here we've got our start, and then an arrow saying this is the direction it's going. That's very important. We have our two inputs, they're parallelograms. We have our lovely diamond, or as I've been told, a rhombus, but in computing terms we say diamond always. That's where we ask our question. Now the storage isn't of the green ball, that's not an output. That's a process because you're not outputting any data, you're just storing it. So we keep that for this term as a process. Repeat it for the red. Now at the very bottom you notice a big set of arrows going all the way back up to the top, and that's our loop. Most programs loop. When we get to the very top of that loop, you'll notice I've made sure there's an arrow. Now think of it like going down the wrong way of a one-way street. You come up to a T-junction, you need to know which way you can go and which way you can't. So I had to make it very clear with the arrows which way the flow is going. Okay. So let's have a look at these lovely rhombuses, these diamonds. You can use them to ask questions. The rules are this. It must always have one input and one input only. You can join before that, but it goes into one input, and it must have two outputs. And it's a question. In this case, is the water boiling? Yes, no. It could be 1, 0, true, false, male, female, anything that can be done in what we call a binary or Boolean. Because remember, computers have to ask very simple questions. In this case, it's asking, is the water boiling? And it will keep asking that question. It won't get tired, it won't get bored, it will just keep doing it until the water's boiling. And then it moves on. Right, so that is our diamonds. Now we move on. Now we come to our Terminator. Okay, not Arnold Schwarzenegger, but the Terminator is, as in terminus, to stop. You know, it's a start-stop. It's like a railway terminus. You have to denote this to say we're starting a program, or occasionally you would also say we're stopping the program at this point. So it's very important that you use that exact symbol. It's not a rounded rectangle. You notice that although there's a flat top and bottom, there is no flat edge on either left or right. Okay, next. Right, our decisions. As I said before, it has to be yes or no. We call this Boolean, named after Charles Boole, who was a teacher who invented the idea of logic in the first place. So in honor of him, we've named this whole branch of mathematics and thinking Boolean. And you always have a yes, no, true, false, something on the outside there, and the question on the inside. Those questions can be all sorts of things. They can be mathematical, physical. It's just as long as you can resolve it into either yes or no, or true or false, or whatever. Okay. Now, inputting data. In a computer, we talk about data. Not physical things, but say the name of a person, the age of a person, the temperature. These are all data. When you export data, quite often you've turned it into something useful, and then we tend to refer to it as information. So in weather systems, we take satellite data, we take weather station data, we take buoy data off the oceans. We put that into a computer. The computer does lots of stuff to it, and out comes information. It's going to be rainy, it's going to be sunny. That's useful information for us. The data went in. Sometimes you can also output data as well. But we tend to talk in terms of data being those things. Intangible, the things you can't touch. It doesn't apply to physical objects. The cat is not data. No matter how much you try to make it, when you put the cat out for the night, you're not outputting data, you're doing a physical action. So we deal with that in a different way. The way we deal with putting the cat out and that kind of thing is we call it a process. So a process, we actually, instead of a parallelogram, we use a standard rectangle. And that's everything else. Any physical action, in this case we use it for storage as well. Anything that's not an input or output of data, not a decision, and not a start-stop, we call a process. And those processes, they can be physical, they can be mathematical, like the price plus VAT, or storage. And we can represent all of this by rectangles. Very easy. So if in doubt, make it a process. Okay. There are other symbols. Here we've got two, store and hard drive, which conceivably you might want to use. And this other one, that's the international symbol for storing on punch tape. But nobody ever really uses punch tape anymore. So in terms of school, we just don't worry about these other symbols. There are lots and lots of them. And they can be for all sorts of different jobs, whether it be plumbing, engineering, human resources. There are lots and lots of them. So we just tend to do input, process, output, and decisions. We don't worry about these ones, but they do exist. So if you see them, don't panic. We just don't worry about them. Okay. Now, flowcharts can get quite big. The last thing I want you to do is go halfway down a page or to the bottom of a page and then reach for the sellotape to make the page even longer. There's a much cleaner way of doing it is we can just use a connector. And if we look at the flow of this connector, through comes, that's our black dot, across he comes to the first connector, teleports out, teleports in, and carries on. So you can have, notice it's A1 on both, and notice the direction of flow is very clear. There's an arrow going into the first one, an arrow coming out of the second one. It's very important. So we use these as connectors, as jumps. And you can have them going down, you can have them up, you can have more than one on the same page. It's very handy. Right, finally, subroutines. Now, say for example you're making tea or coffee. Well, both will require you to ask the same question, do you want milk? So on your main flowchart, you would use this kind of rectangle with a rectangle inside it. Technically, we call it a predefined process. Basically, you're saying add milk, and beforehand you defined this little flowchart on the right where you ask, do you want milk or not? And if yes, pour the milk. So that's a predefined process. Now, you don't then need to keep redoing the do you want milk or not. You've done it once. Notice it's using a terminator. You can use stop, you can use exit, you can use, yep. I've kept add milk at the top though so people know what the process is. There's no hard or fast rule about that one. As long as it is clear what that process is and where it starts and where it stops, and that you do actually use the shape right. That's all that matters. The words inside just have to be clear for someone to understand. And on the left-hand side, when you call it, which we say calling a subroutine, we can use this predefined process, which is a rectangle inside a rectangle. And that's flowcharts. There you go.